All right, y'all, we made it this far. Let's keep going. 2.6 String objects, concatenation, literals, and more. Probably one of the longer lesson titles we will see. We're going to start off talking about string objects. We'll be working on that learning objective for string class, create string objects, and call string methods. Did you ever have a friend who was intent on telling you a joke even though you already knew it? But they continued to go on with it, and you weren't quite sure what to do with this series of words they were telling you, and then you just had to wait until they were done. So we're going to see how the computer stores words. So on our left, we have an object declaration and instantiation statement. And on our right, we have a variable declaration and initialization statement. On the bottom, we are declaring a string variable and assigning it the string literal hello. But what kind of statement is it? String is a class, so we are making an object, but we are not instantiating by calling a constructor. We are not requesting space in memory by using that keyword new. So what kind of statement is this? Well, a string is a special kind of statement, and we're going to see how it's stored in memory. So you can see in our code, we are declaring three strings, word1, word2, and word3. We are assigning word1 the string literal of orange. When the computer sees this, it looks to see if it already knows the word orange. Now in the heap memory, the computer has a special place for strings called the string pool. So it will look in that string pool to see if it knows the word orange. We just started this program, so it doesn't know any words yet. So it's going to move that in to the first spot in the string pool. It's not going to bother giving it a name, it's just going to move in the value. And since we declared a variable word1, that's going to go up in stack memory. And we are going to assign that the memory address of where to find that string in the string pool. On line 3 of our code, we are declaring word2, and we are assigning it the string literal of orange. So again, when Java sees that we have a string literal, it goes to the string pool to see if it knows that word, and it does. It's already in the first place in the string pool, so it doesn't bother putting it in the string pool again. So in stack memory, we will get our word2, and we will get the same memory address of where the other orange is. On line 4, we are assigning the string literal of banana. Java goes to the string pool. It does not know that word, so it moves it into the next spot in the string pool. It doesn't bother to give it a name, and then it creates our variable in stack memory and assigns it the memory address of where to find that word in the string pool. So word1 and word2 are pointing to the same place in heap memory. Just to make things more confusing, we can create strings using the keyword new and calling the string constructor because it is a class. Starting on line 2, we have the string literal orange being assigned to word1. Java will go into our string pool. It doesn't see orange in there, so it will move orange into the string pool, and then it will create the variable in stack memory and assign the memory address to it. Now on line 3, we are creating a new string and we're passing in the string literal orange. Whenever we call the string constructor, Java doesn't look for the string in the string pool anymore. It will just automatically create this new string, even if there was a copy of that string already in there. So we are telling Java to make a new string orange, and so that's going to move in at the next available spot in the string pool. And then we will assign that memory location to word2. And so now word1 and word2 are pointing to two different oranges in the string pool. Line 4 works the same way as before. It looks in the string pool for banana, it doesn't see it, moves it into the string pool, and then assigns the memory address to word3. So we're going to look at one more situation. Starting off with line 2, we're creating orange in the string pool. we are creating word1 in stack and assigning it the memory location of that orange. Line 3, we are making a new orange in the string pool, and we are assigning word2 to that memory location. And now on line 4, we are creating the variable word3 and we are assigning it the string literal orange. So we're not using a constructor call, so we're not going to make a new orange in the string pool. Java will look in the string pool to see if orange already exists. We can see that it's already in there twice, so the question is, which orange is Java going to pick? Well, Java will look for the first occurrence of that word in the string pool and finds it in the first memory location, and that's what word3 is assigned. So word1 and word3 point to the same orange, and word2 points to a different orange. So here's a breakdown of those steps. If we just assign a string variable, a string literal, Java looks for the value in the string pool. If not found, it stores that string in the string pool. It finds the memory address of the first occurrence of that word in the string pool and stores a reference to that memory address in the reference variable. When we create a string by using the keyword new and calling the string constructor, it moves that word into the string pool even if it already exists, and it stores a reference to that newly added string to the reference variable. This aligns with our essential knowledge. String objects can be created by using string literals or by calling the string class constructor. Next, we're going to look at concatenation. Same learning objective for string class, create string objects, call string methods. So what happens if you're walking down the street with a jar of peanut butter and then you run into somebody who's walking down the street with a jar of jelly? When you have peanut butter plus jelly, you're going to get Smucker's Goober peanut butter jelly. Yes, that's a real thing. You have peanut butter and jelly both in the same jar. So we can add our strings together too. So on line 2, we are declaring a string named str1, and we are assigning it the string literal peanut butter. On line 3, we're declaring a string named str2, and we are assigning it str1 plus the string literal jelly. So what is going to be in str2 when we print it out? Well, let's take a look at that expression from line 3, str1 plus jelly. You see in the middle we have that plus sign. That is not the normal addition operator that we've been using. That is a new operator called the concatenation operator. It's confusing because it uses the very same symbol as the addition operator. It performs a different task and it has a different level of precedence. So we slot this into our precedence table at level 11. It's still that same plus sign, but it is the concatenation operator. And the operation that we see when we see this operator, we create a new string by joining two strings together. So we can take the string by, and then we can concatenate onto it in E, and then we get the word bye. So to use that concatenation operator, the first thing we would do, we would evaluate str1. In memory, str1 is the string peanut butter, and then we're going to concatenate the string jelly. What this evaluates to is peanut butter jelly. We did not have a space in there, so it's not going to concatenate a space between peanut butter and jelly. It's just going to put the characters together just like they were. It doesn't put any extra characters in the middle. So when we do string concatenation, we can concatenate a string literal to a string literal. So if we have the string literal Peter plus the string literal Parker, we're going to get Peter Parker, no space in the middle. After the concatenation, the new string will be added to the string pool if it's not already there. This aligns with our essential knowledge. String objects are immutable, meaning that string methods do not change the string object. String objects can be concatenated using the concatenation or the concatenate and assign operator, resulting in a new string object. So immutable means that a value cannot be changed once it's created. Once a string goes into the string pool, we cannot change that string. If we concatenate another string onto it, we just make a new entry into the string pool. We will never change that original string in the string pool. Besides for concatenating string literals, we can concatenate string objects. So we can take some string literals and put them into string variables like we see on lines 1 and 2. We're taking the string literal Miles and assigning it to first name, and the string literal Morales, and we are assigning that to last name. On line 3, we are concatenating those two string objects together, first name plus last name. And so in the console, we will get Miles Morales. And we can concatenate string objects and string literals if we want to. So we have our string object first name being assigned Gwen, our string last name being assigned Stacy, and then we have our string full name in which we are concatenating the string object first name, and then we are concatenating the string literal of a single space, and then we are concatenating the string object last name. And so when we print out full name, we will have Gwen, that single space, and Stacy. We can also concatenate string objects and primitive data types. So we have an integer variable area, and we are assigning it 12. Then we have a string called output, which we are assigning it the string literal area plus the variable area. That will print out that string literal area colon space, and also it will print out the value of 12, but that won't be the integer 12, that will be the string value of 12. Java will upcast primitive data types to strings for you. This aligns with our essential knowledge. Primitive values can be concatenated with a string object. This causes implicit conversion of the values to string objects. You can also use the concatenate and assign operator to add a string to an already existing string. So on line 1, we are declaring a string named sandwich. We are assigning it the string literal peanut butter. And then on line 2, we are going to concatenate into that already existing string, and we're going to add the string literal space and space jelly. So when we print out that variable sandwich, it has that entire string peanut butter and jelly. When we concatenate into an already existing string, that original string of peanut butter stays in the string pool. We are not changing that string in the string pool. A new string object of peanut butter and jelly gets added to the string pool, and then the memory address is stored in the variable sandwich. So sandwich holds a memory address. It originally pointed to peanut butter in the string pool. Now it points to a different location in the string pool that holds peanut butter and jelly. Our next topic deals with escape sequences, again with the same learning objective. For string class, create string objects, call string methods. So on the left, we have two ordinary people. On the top, we have mild-mannered newspaper reporter Clark Kent. On the bottom, we have billionaire playboy Bruce Wayne. Both of these characters have alter egos. Something happens that changes them from these normal people into something else. So Clark Kent changes into Superman, and Bruce Wayne changes into Batman. We have special string characters that do the same thing. So we're going to look at 4 of those characters, and we're going to see first what their normal behavior is. Then we're going to see how to turn them into their superpowered form and see what their superpower behavior is. So starting off with the character N, when we use the character N in a string, it is just a regular character N. With the character T, when we use that in a string, that is just the regular character T. Now the double quote symbol we cannot use inside of a string because that is not a regular character to Java. To Java, that's how we tell Java that we are going to either start or stop making a string literal. Those are our string literal containers. And the last character is the backslash character. That is not the normal backslash to Java. To Java, that means we are starting an escape sequence. Now we are going to look at these characters' special powers. In order to transform them into their superhero state, we are going to put a backslash before them. When we use a backslash in a character, we are creating something known as an escape sequence. An escape sequence is a sequence of characters that has a special meaning inside of a string. If we have a backslash n inside of our string literal, we are telling Java to create a new line. It will not print that n character in the console. It will not print that backslash character in the console. Instead, it will move down to a new line in the console. If we put a backslash t into a string literal, again, that backslash will not be printed to the console and the t will not be printed to the console. Instead, we are going to get this alternate action of a tab character being written in the console. If we do a backslash with a double quote, that stops that double quote from being the string literal container and it just turns it into a regular double quote. So then we can put that double quote inside of a string literal. And if we have a backslash backslash, that just prints out the normal character of a backslash. Because if we look on the left side table, the backslash character isn't the normal backslash to the computer. That's how we start an escape sequence. To tell Java that we want to use this backslash in a different way, we need to put a backslash in front of it. Let's take a look at some of these examples. Our first statement, we have Batman and Robin. We do not have an escape sequence in there because we do not have a backslash. So every character will print out like normal, and we will get Batman and Robin in the output. You'll notice that I'm using underscores for spaces just so you can see where the space would be in the console. In our second example, we do have an escape sequence. We have that backslash n in the middle. Now that backslash and the n will not be printed to the console. On the first line, we would have Batman and space because that's what we have before the backslash n. The backslash n tells Java to move to the next line, and then it'll print out the rest of the characters, which is space Robin. On the third line, we have a backslash t right in the middle, no spaces around it. We don't need to have spaces around an escape sequence. Right when Java sees that backslash, it knows to treat that next character differently. In our console, we will have Batman, and then we will have a tab space, and then we will have Robin. The fourth line, we have two escape sequences in there. It's the same escape sequence used twice. First, we have the backslash double quote before the H in hello, and then we have the backslash double quote after the O in hello. We have to do that if we want to print out those double quote characters because those double quote characters are used to contain the entire string. If we did not have this backslash here, Java would think we were using this double quote to end our string literal, and it would just think that this is our string literal. So that would print out I said, and then in quotes, hello to the console. Finally, we have the string literal, the backslash, and inside parentheses, we have two backslashes. Well, that first backslash starts our escape sequence. It tells it to treat that next character differently. That next character is the backslash to which Java normally think means starts an escape sequence, but its second action is just the backslash character. So we just print out a single backslash. This aligns with our essential knowledge. Escape sequences start with a backslash and have a special meaning in Java. Escape sequences used in this course include backslash double quote, backslash backslash, and backslash n. That wraps up 2.6. Rate how you feel on that learning objective. Make sure that you hit me up with any questions or concerns that you have regarding these concepts. Join us in our next video and keep programming.